Well, we have a brand new parent function that is closely related to the cubic function. It's called the cube root function. So we may or may not have already done that in class, or maybe I'm doing that in a video. But nevertheless, we have the cubic function here, and if we want to find its inverse, the first thing we do, remember, is substitute y for f of x, and then we interchange the x and the y. So we have, instead of y equals x cubed minus 1, we have x equals y cubed minus 1. So how do we handle that? How do we solve for y when y is being cubed? Well, we're going to add 1 first of all. We're going to add 1 to both sides, and we're going to get y cubed equals x plus 1. So just the same way we undid all the other functions when we were solving for a variable, to undo y being taken to the third power, we take the cube root of both sides, and we get the cube root of y cubed. Well, that's y. The cube root of x plus 1 is the cube root of x plus 1. So if we were to draw the graph of y equals x cubed minus 1, we know we take the graph of y equals x cubed and we drop it down 1 unit. And we could put a -1 in there. Put -1, we'd get -1 cubed minus 1, that's -2, and then -2 cubed is -8. 1, 2, 3, 4, 5, 6, 7, 8, and then minus 1 is down there. So it's way down here somewhere. Comes up. Remember, the inflection point is right there at 0, -1, and then we go up there and we climb pretty quickly. So there's f of x equals x cubed minus 1. And then the cube root of x plus 1, we know that the cube root of x, so y equals cube root of x, if you remember, looks like that. And if we add 1 to the x, then basically we are replacing x with x plus 1. What does that mean? It means we move this parent function 1 to the left. So we'll do that one in green. 1 to the left goes right there. And we know it's going to go through those 2 points there. So we come way over here, and the inflection point is right there at -1, 0. And so there we have it. We have both of these graphs, then f and f inverse are symmetrical with respect to the line y equals x. And all right, well, let's go ahead and figure out the domain and range of each. F, the domain, is all real numbers. The range of f, all real numbers. Is it a function? Yes, because it's, well, it is a function. It's given to us as a function, so it's going to be a function. And then f inverse, the domain is all real numbers. The range of f inverse, again, all real numbers. And then, is it a function? Yes, it is a function. And it's also 1-to-1. Again, 1-to-1 functions have inverses that are also 1-to-1. So there you have it. Let's see, do we need to do anything else? How could we restrict the domain? No, we don't have to do that. Now, let's start with a cube root function, and let's see if we can figure out how to find its inverse. So finding an inverse again means you substitute y for f of x. We write this as 2 times the cube root of x plus 1 plus 2, and then we're gonna interchange the x and the y. So we put x here and we put y here. I'm gonna write small here, not a lot of room. And let's go up here. Let's go ahead and add 2 to both, subtract 2 from both sides, and we're gonna also switch sides here. So we're gonna do this all in one shot because we're running short on room. 2 times the cube root of y plus 1, and then equal to x minus 2. So I brought the minus 2, I subtracted the 2, so I brought the 2 over to the x side, and then I just switched sides. So hopefully that wasn't too much. If you want to try that on your own and then rewind the video, feel free to do that. And then from here, we have to isolate the cube root, and so isolating that means we're going to divide both sides by 2, so the 2's will cancel. Now we have the cube root of y plus 1 is equal to x minus 2 all over 2. And now we want to undo what's being done to the variable y, because we want to get y by itself. So to undo cube root, we have to cube both sides. To undo cube root, we cube both sides. And so we get y plus 1 on the left, and we get x minus 2 over 2 cubed on the right. And boy, we're really running out of room here. My apologies. Since we don't have any restrictions on these, let's continue this down here. So y equals f inverse of x. We're going to subtract 1 from both sides, equals x minus 2 over 2 cubed, and then minus 1. So that's our inverse function. And you know what I forgot to do? I forgot to write this other one over here as inverse of f of x. So f inverse of x is cube root of x plus 1. And I should write that down here as well. So on the graph, we have f inverse of x equals the cube root of x plus 1. And then the graph of, you know what, I'll continue with the graph of this example here in the next video, because I'm running out of time.